Hello, D. Alfred Ostrowski here. Welcome to day 3 of my 20-day challenge. In this recording, I'm going to be going through assertion testing through the HardHat framework on the Hello World program that was presented earlier. Now, I wanted to point out I'm labeling these videos, but you might want to skip around. They're not presented to where you have to follow through the steps or the days. If you have a particular topic that you want to brush up on or you're not familiar with and you're familiar with the others, feel free to skip around. Okay, so as usual, I'm running a C5 instance. I have the prerequisite installation. If you don't have that already, you might want to look at the Node.js version 22 installation video, or what I've labeled as the day 0 of my 20-day challenge. But I still have all the steps listed in the README file with the associated GitHub, so you could follow through that. But I'm taking the liberty of already installing that. I did a fresh instance here. So we're starting right at the point here of running through the installations here that I've labeled with the day 0. Okay, so I'm up and running. I got a terminal, and I only need one terminal here. Okay, I don't need to run the HardHat node. Okay, the testing framework allows me to run the tests and the deployment just as if I was running it against the established HardHat node as I would typically do. So I'm just going to be doing an npx HardHat test that takes everything from the test directory and will execute it appropriately. So I've designed a number of tests around Hello World, and this is super important in the context of blockchain development, that you have to run tests against your smart contract a lot more and frequently than you would typically do because of the immutable aspect of anything that is generated from a smart contract is in perpetuity, okay, on the network. So you don't want to have a low confidence. You need an absolute high confidence level of everything that's running. And there's no better way to start than taking our Hello World and just test it to death and really understand a lot more than the structural aspect of a simple Hello World type program that most programmers are immediately familiar with. There's a lot of dynamics happening behind the scenes here in the context of the blockchain. I want to introduce that to you at this level. That way, it's easier to step into these more complicated examples, even with, let's say, LockJS, that is the default assertion test type program that is presented with the HardHat framework, which to the uninitiated may be a little bit more intimidating than it really needs to be. Okay, so I'm going to follow through my instructions here. The next thing I'm going to do is create a test directory, as I usually done. And again, you don't have to start with a fresh instance each time. I do to ensure to the best of my capability. Okay, there's nothing guaranteed with the cloud, though it is probably the best way to my experience, to share these types of solutions that someone else can get it up and running on their own accord. And I want to make note that you can run several projects, obviously, on top of the prerequisite installation that I presented in the day 0. You can just initiate as separate projects. If you're running a lot of projects, which I've done, you will run out of resources. So you want to keep an eye on that as well. Okay, so I'm here. Let's continue. I want to go to CD to test. And I'm going to do an npx HardHat init. And I do like to create new projects every time. And it's interesting to note, and again, I'm not pausing this out because it's going to work pretty fast with C5 instance as it usually does. Some tutorials have you installing the toolbox, as you see installing here. It's not necessary. Okay, if I do the default, at least for what I want to do at this point, I can do the simple npx HardHat init, and it's going to give me everything I need to get up and running with the testing environment. To get a little more sophisticated, maybe at times you might want to pull in some extra libraries, but not for what we're doing here. Okay, so again, most importantly, my priority here is to get you up and running as fast as possible and get these examples and get you to the point where you're modifying this. I want to encourage you to do that, especially in this example. That's how we gain ownership, right, as developers, right? Being able to anticipate what that change will result in and successfully make that change and be able to anticipate the results and get it to work appropriately, right? So next thing I'm going to do, that I've created the test directory, I'm going to pull my contract. So this contract has one minor modification, and I'm going to show that to you right now as I put it in here, is I am initializing that string, okay, as if I would with a constructor. However, I'm not relying on a constructor, though smart contracts in Solidity obviously do support constructors, but we'll get to that point at a later point in time, right? So here I have a small modification. I'm actually initializing that string. I'm going to test that initialization as one of my assertion testing. So that was the purpose of doing that in the first place. So again, I'm cut pasting this in here. In my Solidity contract in here. Again, I'm taking public, this public variable, and I'm storing it. And you're going to see how that's going to work out in the smart contract. And again, if you want to see this run, you can look at the two prior videos where I run it from the command line as well as from the initiated from React.js, right? So next thing following through here is we're going to pull in our test example. So I'm going to go to the test directory that's created here. Now I have a log.js test. We could take a look at that later on in further videos. Right now, I'm just going to delete that. That's created with the framework. So if just for brevity, okay, I'm going to remove that. And again, you could look some of the aspects that are presented here at a later point in time. Here I'm going to pull in the set suite of tests that I developed for this. And I put associated reference of what inspired this particular set of tests. And this is appropriately named Hello.js. So copy that in here. First things first, as usual, let's make sure it works. And I'm going to break it down line by line and start doing some modifications and explain it exactly what's going on here. So I can simply do npx HardHat test. So take everything from that test directory and it will execute it, okay, in appropriate fashion. So pass all my tests and I print out some diagnostics here. I can actually, I'll clean it up before we're done, but you can see the output here, hello deployment, hello variable test, data console log some of the variables here with the addresses so we can look at the differences and appreciate that. I did a couple set hello tests. I should be differentiating these a little bit and we can moving forward. And then I have a final test here. So let's break it down. Let's look at the program. So I can go to the testing framework and start from the top here. Okay, clean up some extra space here. First thing, we are leveraging the chai library and the expect function. Okay, so the require is pulling that in so we can reference it from our testing script. First reserved word here is the describe function. It's interesting to note, describe function only allows you to really add documentation to the output and format it appropriately. It doesn't really do any more functionality beyond that. It's not named as an async by best practice. And it's interesting to note, okay, and I can prove that right now, that I don't need describe to run an assertion test. Okay, it's not best practice, okay, but again, just to have an appreciation of exactly what describe is buying for us and it is buying for us, it gave us the same output, okay, except one thing, okay, it did not present the deployment label here, okay. So if you're running a lot of assertion tests, of course, if you have time between the testing, this can help out a lot to have that. So just wanted to show exactly what that is buying for you. It's also interesting to note I can put a higher level describe here. I can say describe put in as many as you want, okay, but obviously you're going to not necessarily need it in most instances, but again, this is how you get uh, the ownership, right? Just to be able to make these changes and have the confidence of what's going on here. So I can call it a higher level describe, and I can wrap all the tests in this contract. Pull up my insert variable here and run that. And this runs as appropriate, okay? And what it generates for me is indents everything appropriately and it adds the appropriate description. So I call this a higher level describe, and all of the insertion tests are fit neatly below that. So let's proceed. Now, since I didn't really need it, I'll just pull that out just to keep this clean, okay? And not forget the brackets and quotes at the bottom, okay? So the first test here, I have an it function that's described as an asynchronous function in similar fashion. And this invokes expect. It's interesting to note, and I did this in some of the further it functions, just more for brevity, but you would typically pair a single expect test within an it function. And again, it allows for it to run in asynchronous fashion, as well as the appropriate label that's being displayed here. Okay, in this test, I'm just testing whether it's able to be deployed to the network appropriately. And this is just performing the deploy contract, okay, and with the appropriately named contract, and then have the test here just for the variable. So it's not returning some type of error code or something, okay? So it just returns appropriately, and it comes back with the message contract has been deployed. The next test, I have a hello variable test. Now, if you recall, I just described where I have in the contract, I did an initialization of that variable, which I didn't have prior. Okay, that was to support this test here. So here, I do another deployment. I would describe it, and then I do the deploy contract. And in this case, I call stored data. It's a public function, so I can invoke it as a method and return that variable. In this case, I test it against the message hello world, and it passes successfully because that is the appropriate message that I put in my smart contract. I can make it fail, right? I can put in hello world X, and now it's going to fail for me. Why? Because I tested against another variable, and you can see hello world was expected to equal hello world X, but obviously it doesn't, so that failed. Okay, so again, in some cases, you're going to want to set up tests that fail appropriately. And again, this is accomplishing a few purposes. Okay, it supports the maintenance of the smart contract, it's self-documenting, and in the exercise of doing this in and of itself proves without a doubt that you have a very good confidence of how your smart contract is. Next, I have a couple expect tests here to my earlier point. Perhaps not really the best practice, but just for brevity, I packed this all in here because they're very related. And I designed this test with a couple things in mind to add a little bit more of understanding of the deployment of smart contracts and the management of the owner accounts and the management and description and internal description of your smart contract associated addresses. Now, if you recall from the day one video, okay, and even the second video where you have addresses that are returned, that first address is the one is typically leveraged for the, not typically always, okay, it's always deployed is the deployment address. If you do a operation, that's the account that's charged because it's the owner of that smart contract. Okay, so here again, I do the deploy and I pull in the contract address here. And here I do two get signers. Here I make an assignment to the deployer with the square bracket is giving me the functional equivalent of the first position of owners 0. And we print that out here. You can see exactly that they're the same. That's why I had the console logs here. We'll take a look at that now. Now you have an idea exactly where it came from. Now, the thing I want to point out here, so all these tests, if you notice, I'm doing a redeployment of that contract. In most cases, when you have a more expansive deployment, let's say I'm adding in a lot of values that are going to be passed into a constructor or something, you're going to pack that into a function and it's going to be called from that here. It doesn't make a whole lot of sense to have a one-line invocation of a function that's really just going to be not much more than one line. Okay, so, but I'm doing the deployment. And the idea is to deploy the contract for every individual test that a prior test does not in any means influence any subsequent tests or the associated output. Okay, so you have a fresh, clean slate every time I design a test. And for that reason, I want to, through calling a function that does it for me, or copying that code directly in here, which I did again, as this gets bigger, it's not going to be the best practice. I'm going to expedite. Again, I don't want to introduce too many concepts in this single video. Well, we want that first start right so we can have an unadulterated test and separate that from any of the other tests and influence. So here I have two expect functions. The deployer to deployer, obviously it's going to be equal. But here I took the deployer address and from the contract, so this proves that I have that address associated with that account is associated with the address. And we can see that I have to subscript the JSON under runner address. If you look at the JSON, it'll have a runner key at a lower level hierarchy, and that's going to reference the address. Okay, so I can't just take HardHat hello address, and that's the distinction, and that's why I have that here, that there is a distinction between HardHat address and HardHat runner address. And when you look at the JSON-based descriptions and the ABI descriptions, interface-based JSON influence descriptions or implemented descriptions, that's the difference. Okay, so again, these are the types of nuances that go well beyond your set get operations in a hello world. It's about understanding the blockchain, how we engage with it, how we test. Okay, the testing is super important. So again, with this in mind, let's just take a look at the deployer address, owners, and the owner's address. Okay, and run that, and just again take a look at the output, which the output is right here. I can just take a look at that. But I can pull those console logs out of it. It's really, we'll clean up my code here a little bit, right? So, but I wanted to demonstrate that. So here I have the HardHat Ether signer. I have the associate address, and this address should be familiar, right? When you get your 20 accounts from the node, this is always that first account, okay? And the deployer address, again, that is returning the same value. And the owner's at 0, it looks exactly the same. So you can take a look at that and match it up appropriately. And if I print out the contract characterization, you're going to see that runner reference. And you can take the JSON-based format and match it up appropriately. And again, you want to have a good idea to learn how to parse that JSON information and understand the difference between the contract has an address and the deployer, the owner of that contract, has a separate address. So here we're making that distinction here. And we'll build on this right as we go on, but let me just pull this out here. I've left this in the posted a GitHub example, but you wouldn't obviously leave this as a production. This is just more for experimentation, and if something's not working, it's always good to, I like to, okay, just dump it out at the command line and take a look at the output, right, as we're running it. Here I'm testing the set operation, and it's a similar format as before, except in this operation, I do a set, and I call hello world again, and I do a get. It's noted I need an await here. and I test it against hello again. I can change that as I did before and make it fail and make it pass, but I think you get the idea at this point, right? Here I am doing another test, but in this case, I'm doing it from owner. So why would I do this? Okay, when you don't have a wallet, these type of operations are handled when you engage with a wallet, which we haven't introduced yet. So again, there's a lot more moving parts here behind the scenes with smart contract and engagement with the blockchain that goes well beyond a Hello World style program. However, they are all in play here. Here, I'm invoking it from owners, and I need to invoke it from the owner account. Otherwise, it's going to generate an error. In this case, I have a try and catch setup, and here it'll generate the appropriate error. I have owners at 0, and the owners at 0 is that account that we just looked at, the address, the 2266, but the first account. And here I have another variation of that, which is a duplicate of the code. However, I initially had it to set it up to fail. Latency a little bit here. Okay. So I can change this, okay, and make it fail. I can change it to 1 and we'll change it back again. And we're going to see it fail, okay. So there you go. If I pass in one fail, test my set function. It was an address mismatch. Caller's not the owner, okay. And I change it back and I'm going to have it work appropriately. So I had it set it up with duplicate code, 1 for the test, 1 for the fail, just to confirm my understanding. And so that's it. Hope this helps. All the code, again, is on the associated GitHub. Thanks for listening. See you on the next video. Thanks.